So in these sets of videos, we're moving away from our Suvat equations for constant acceleration and consider cases of non-constant acceleration. Therefore, we need to define a few little things. In the first instance, we have time, t, and that's going to be defined as our independent variable. Alongside this, we're going to have our displacement. Now, in this case, our displacement is not going to be called s, but it's going to be defined as x. Okay, and that's going to be our dependent variable. So what that technically means is x depends on t, or x is a function of t. So we could obviously write x is equal to ft. So to give you an example of what a displacement equation might look like in this case, we could say that x is equal to 2t cubed minus 3t squared plus 5, and that would be a equation of displacement in non-constant acceleration. Following on from this, we would need to define what velocity and acceleration looks like. Well, as you can see, now we have these functions of x being a function of t. We can then say, well, velocity must be the change in x with respect to time. So v will therefore equal dx by dt, i.e. the differential of our function. If we then go on to look at acceleration, our acceleration a is going to be the change in velocity over time, or if we consider it, it would be the second differential of displacement with respect to time. So what we're going to do is perhaps use this example at the top of the screen, and we're going to look at what the velocity would look like and what the acceleration function would look like. So now I know that displacement is 2t cubed minus 3t squared plus 5. My velocity would be the differential of x with respect to t, which would be 6t squared minus 6t, and that's it. My acceleration would be dv by dt. Now obviously we've just differentiated dx by dt to get v, so my acceleration function is just this differential again, which is 12t take away 6.